Mr. Academia, Mr. Academia, Mr. Academia. Thank you for watching all our videos. Thank you for liking and sharing and commenting on our videos. Continue to invite more to subscribe to our channel such that you get notifications for all our new lesson videos. For today, we are going to look at how we use matrices to solve simultaneous equations. So we know that a simultaneous equation is an equation which has two unknowns. That is, if there are two unknowns, then we shall be having two equations. If there are three unknowns, we shall be having three equations. So if we take a system of equations like this one here, so these two equations have two unknowns, and therefore we call these two equations simultaneous equation. The first unknown is x and the second unknown is y. The first thing we do when using matrices is that we write the system of equations. We transform it into a matrix, or we write it in matrix form. So basically, when we write it in matrix form, this is what it becomes. So first of all, we go transform the coefficients, that is the coefficient of x and the coefficient of y, we write them in matrix form so that we get a matrix of coefficients, which is this one here. If the equation is not arranged properly, make sure that the x and the y occupy same positions in the two equations. So you can see x comes first and then y comes next, and then the constants come after the equal signs. So next we write x and y, which are the unknowns in their own column matrix, and finally we have the last part, which has these other constants here. So what we have is we have formed a matrix which is from our simultaneous equation. So the next step is we have to go ahead and solve this matrix here. So now we are required to solve this. So the first part that we do is that we look for the inverse of this matrix of coefficients here. Look for the inverse of this matrix of coefficients, and then after we shall multiply it on both sides. So to get the inverse of this matrix here, of course, since we are dealing with this one, we'll get it, then after multiply it on both sides. So these are the steps that we follow. So the matrix A is this matrix here. So we get its inverse, we multiply it on both sides. So you can see the inverse is multiplied this side, and the inverse is also multiplied on this side. So remember, a matrix, when you multiply it with its inverse, we end up getting an identity matrix. So afterwards, we can use that identity matrix to get the answer, because if you multiply the identity matrix into x and y, you end up getting x and y, and then we shall have to solve the right hand side to end up getting our answer. So let's see what we get in this case here. If we have the inverse of the matrix A, which is written as A inverse, it can be got, and this will be got by getting 1 over determinant. So remember, determinant is 3 minus 4, which is -1, times the partial inverse, whereby we change the signs of these and then we exchange these ones such that the inverse is got as this one here. Then after, we go to the next step where we multiply the inverse on both sides of the equation. So you can see we are multiplying the inverse on both sides. That is the second step, and basically you can see what happens when we multiply it on both sides. So when we multiply this side, this one will give us an identity matrix, which we multiply with x and y to get x and y. So you can see the identity matrix that we get that side, which is multiplied into x and y. And then on the right hand side, we might multiply this with this, we end up getting that one there as our answer. So finally, x and y equals to 5, 2. So after, we can go ahead and equate coefficients, x to 5 and y to -2, and state our answers for the equation there. So you can see that x equals to 5 and y equals to -2. If you want, you can still check with the equation whether the answer we have is correct by substituting the same values there. So if you substitute, I'm sure you're still getting the same answer there. So meaning that our solution has worked very well. So you can also try out this and see what you get. I'm sure you'll be able to get these answers here. So try out, use matrix method to solve that equation and see what you get. I'm sure you'll be able to get that answer there. So thank you for watching. Remember to subscribe, press that button, subscribe to Mr. Academia, continue learning with us. Thank you for watching.